In this video lecture, I will explain a C program to compute the roots of the quadratic equation. So you know that what is the quadratic equation? Quadratic equation is ax square plus bx plus c, and there are two roots for any quadratic equation. Okay, and root 1, we can say root 1 and root 2, and there are three cases. So first we need to calculate the discriminant D, that will be b square minus 4ac, and the three cases are either D will be greater than 0, or D will be equal to 0, or D will be less than 0. So when it is greater than 0, the roots are real and equal, and when it is equal to 0, the roots are real and distinct. Okay, and when D is less than 0, roots are imaginary. So these are the three cases that we need to check here. So, and one more thing is there, if I say the quadratic equation is x square plus bx plus c, and if a is also 0, a is 0, so this becomes 0, and c is also 0, so this also becomes 0. So a and c both are 0. We have bx is equal to 0. So that means we will say that it is not possible to calculate the root. And when we say only a is 0, a is equal to 0, but b is not equal to 0. So only a is 0, that means ax square plus bx plus c. So this part becomes 0, and we'll have bx plus c is equal to 0. So now if I have bx plus c is equal to 0, the equation becomes linear equation. So when the equation is a linear equation, the root will be what? The root will be minus c by b. Okay. So all these cases we have to consider. First we need to check when a and c both are 0. We have to tell it is not possible to calculate the roots of the quadratic equation. Second case can be what? If only a is 0 but b is not equal to 0, the equation will be a linear equation. So then the root will be minus c by b. Otherwise, what will happen? The equation will be a quadratic one, and then there are three cases that we need to consider. So here we will be using nested if else or if else ladder, both the nested if else and if else ladder concept to write the program. So here first what we will be doing, we will be checking, we will be calculating this discriminant, and then we will be checking the condition if D greater than 0. So this is the first condition. If it is greater than 0, we need to calculate the roots. Otherwise, second condition will be else if D is equal to 0, then the roots are real and distinct, and we have to calculate the root. Otherwise, by default, see, if this condition is true, the roots will be real and equal. Otherwise, second condition means else if we will be writing. And if this is also not true, this is also not true, so by default it will go to else part, and this else part will be imaginary root. Okay, so this is how, so this is else if ladder. So here we will be applying else if ladder and nested if else concept. So first we'll see, from the beginning we'll see, we have to write the header file. So we will be writing stdio.h header file, and mat.h also we have written here. Why? Because we are going to use square root function. Why square root function? Because we have to calculate the root of the quadratic equation. For that we need to calculate D, and D is b square minus 4ac, and then the root will be minus b plus minus under root of D by 2a. So this under root I cannot directly write here in program. We need to use the predefined library function sqrt that is defined in math.h header file. So whenever we use any mathematical library function, we need to include math.h, and stdlib.h is used because we will be using the function exit 0. So when I have exit 0 in my exit 0 function in my program, so as soon as this exit 0 is encountered, the program will be terminated. Okay, so that's why this mat.h and stdlib.h header files are used here. Now we are writing main function, and then this is the variable declaration part, and because the quadratic equation is ax square plus bx plus c. So all these a, b, c are the coefficient. We are taking everything as float only. And then disk is for calculating the discriminant. This is the variable name. Disk is a variable name. You can take d or discriminant, any valid identifier you can take. And root 1 and root 2 for calculating the root, because for quadratic equation we are going to have two roots. There is one more variable root we have taken. Why? Because when the equation is a linear one, when a is equal to 0 and b is not equal to 0, this case, okay, so then the linear equation, the root will be minus c by b. So this root is for linear equation, so that the variable name root is for the linear equation. And then we are printing this message, enter the coefficient, and then we are taking input from user a, b, c. These three coefficient value we have to input from the user. Okay, now next what we are doing, we have to check the condition when a and c both are, the coefficient a and c both are 0. So when a and c both are 0, it should print not possible. It is not possible to calculate the root, and exit 0 means we will come out of the program only. The program will be terminated, because when whatever a and c, whatever coefficient value we have inputted, if it is not possible to calculate the root, the program should terminate. So exit 0 function is used. So that means after this, whatever code is written, it will not be executed. The program itself will be terminated. Otherwise, if this condition is not true, the next condition how we will write, else if a is equal to 0 and b is not equal to 0. So here it is a double equal to is used. Okay, a is equal to 0 and b is not equal to 0. That means ax square plus bx plus c, only this part will become 0 and the equation will be a linear equation. So then root will be minus c by b. So that's what we have calculated, and we are printing that root value. Okay, so first condition was when a and c both are 0. Second condition is only a is 0. Else what will happen? It will be a quadratic equation. So then we will write else part. So by default it will be a quadratic equation if these two conditions are not true. These two are not true, then it will go to else. And then we are calculating here disk value. So disk is the discriminant, and that is b square minus 4ac we have calculated. And now we will be checking the three conditions to find the root. If disk greater than 0, this is the first condition. Else if disk is equal to 0, or else by default this part is what? Imaginary root part. By default this will be executed. So when disk greater than 0, my root will be what? Roots will be minus b plus minus under root of b square minus 4ac upon 2a. Okay, so how we will write this? Minus b and under root we cannot write like this, so we are going to use the predefined function sqrt. Okay, sqrt, and disk. So this under root b square minus 4ac is nothing but disk that we have calculated in the previous step. So you can see here this disk is equal to b square minus 4ac. So this, instead of b square minus 4ac, I can write disk now upon 2a. So this is the first, so first root will be, root 1 will be what? Root 1 will be minus b plus under root of d upon 2a. Second root will be minus b minus under root of d upon 2a. So this root 1 and root 2 we are calculating, and then we are going to print. And since everything is of float type, so while printing we need to give the format specifier %f. Okay, and then the second condition is, if suppose roots are not real and distinct, if disk is equal to 0, so then roots will be same. So root 1 is equal to root 2 both. So this whole thing will become 0. When d is equal to 0, the whole thing will become 0. So my root 1 and root 2 both will be what? Minus b upon 2a only. So that's what we are calculating here, and we are going to print that. Okay, and next, if I mean the first case was d greater than 0, if second was else if d is equal to 0, then by default it will go to else part. Here this part will be what? Imaginary root part. Okay, so imaginary root, we are not going to calculate the root, we are just printing the root. So here if the roots are imaginary, we get something like this: a plus ib a minus ib. So why I? Because this discriminant will be minus, it will be less than 0. So that's why this imaginary root, we get roots like this, a plus ib, a minus ib. So what we are doing, root 1 is equal to, we are saying this part is equal to root 1 and this part is equal to root 2. So root 1 we are saying minus b by 2a. Okay, so minus b by 2a plus minus we are saying under root of minus d upon 2a. Okay, so this part we are saying this part is root 1 and this part is root 2. Okay, and then here, because under root of d sqrt, for under root we are using sqrt function, and then I cannot directly just write sqrt disk. In previous step I have written like this. Why? Because the disk was, the value of discriminant was greater than 0 or equal to 0. Here the value of discriminant is less than 0. So then I need to use one more function app, so that will give the absolute value of it. So I should write sqrt and then apps is the predefined function that will give the absolute value of disk, because under root of minus I can't take, upon 2a. So this part is root 2, and then while printing, how I am printing? Percentile f plus I percentile f. So this I am printing as it is, so this I will be printed as it is. Instead of this percentile f, the root 1 value means this value will come. Instead of this second percentile f, this root 2 means this value will come. So the first one will be what? This one is nothing but a plus ib, and the next one will be a minus ib. Okay, so here this one will be a plus ib, and this one is a minus ib. So we are not calculating the root, we are just printing the root. So this first percentile, you will say this first percentile is for root 1, the second percentile is for root 2. So basically we are printing percentile f plus I percentile f minus I percentile f, and then here this first percentile f is for root 1, second percentile is for root 2. Same way, this is for root 1, this is for the second percentile f is for root 2, and root 1 and root 2 I told, because the roots will be, it will be minus b plus minus under root of minus d upon 2a. So we have divided it and we are taking minus b upon 2a plus minus under root of minus d upon 2a. So this part is root 1, this part is root 2. So hope you have understood the concept of this. Thanks for watching.